on behalf of those with us here in this hall and those students and colleagues, alumni who've joined us online, I would like to welcome you for today's lecture. Professor Carlo Cafiero is a good friend. He is a good support, and I am grateful to him for having agreed to deliver this lecture. It's something very interesting, a little intense. So I request him to start right away, and we'll have discussions where we'll come back to a number of issues. Yeah, thank you, Carlo.
Jasim asked me also to say a few words about who I am and why am I competent to talk to such a distinguished group of people. So I am Carlo Cafiero. I work for the United Nations, the FAO. I'm a senior statistician there. I'm in charge of food security and nutrition statistics. Perfect. Before joining FAO, I worked in academia. I was an assistant professor of agricultural economics and policy at the University of Naval, but essentially the last part of my career, I would teach statistics at the Graduate School of Agriculture. I have 2 degrees, 2 PhD degrees and 2 masters, but the PhD degrees are on agricultural and natural resource economics from the University of California, Berkeley, and a degree in agricultural policy from the University of Naples in Italy. So I'm an economist by training, a farmer by education, or initially I was raised up in a farming community, very interested in agriculture and natural resources, in the standard of living in rural community, but then economics. I liked quantitative methods. When I was first introduced to statistics, it resonates to my mind. And nowadays, I consider myself a repentant economist, but somebody that thinks the important fundamental use of statistics in any area of human inquiry, both the natural biological sciences and even more so for the human behavioral and social sciences, where the use of statistics becomes a little bit more sophisticated, and this is the topic of the lecture. I will use food security or food insecurity, which is something that in principle we can measure, as an example. But the topics that I'm going to cover are much more general in the sense that I think some ideas can be applied to other areas of economic research. So I hope it will be interesting for most of you. I understand this is being also webcasted live, so there may be other people watching it online. So let me start immediately. What I want to discuss, my talk will be organized around 4 little separate topics, and then I plan to leave sufficient time, half of the total allotted time, for discussion, question and answer. So the first, I will discuss how we can operationally define food insecurity. And operational define means definition that leads to the possibility of measurement. Then I will discuss very briefly what, in my opinion, is the true nature of the process of measurement and what is the role of statistics into measurement, which is something not always heavily emphasized. And then I will use 2 examples. The first example concerns the use of head count, so-called head count method. I see people nodding. I guess any economist at some point has done, is culprit of having counted heads. without realizing that by counting heads, sometimes it's like attaching a judgment. But anyway, what I want to do from the statistical point of view is discuss some subtleties that we need to be very careful when we want to do these things. We're having a distribution. We want to somehow create a partition in the distribution in different classes. And we do this by comparing some variable outcome, measured, observed outcome with a threshold. Less than, more than, this would be the poverty line, this would be the amount of required calories, etc., etc. Then the second example that will allow me to illustrate some of the concept is the possibility of measuring unobservable things. So whether or not make it sense to measure things that cannot be seen, and if it makes sense, how can be done properly. So without further ado, let's start with the definition of food security. Apologies if this is so known to many of you. In 1996, there was the World Food Summit in Rome, in which 192 governments met, and they agreed on this definition. Food security is a situation that exists when all people at all times have physical, social, and economic access to sufficient, safe, and nutritious food that meets their dietary needs and food preference for an active and healthy life. Well, good, nice, ambition. It's a very nice ambition. But if you think about a little bit, this means that food security never exists and will never exist. Because anytime there will be somewhere someone who is not getting the food that they need. So, as a measurable construct, this is very difficult to do. There are myriad ways in which one can be far away from this ideal, and so maybe the distance from the ideal qualified. It's more what we, in principle, can try to measure. But now, let me illustrate, in my opinion, after having worked for 14 years at FAO, what is, to me, the backbone of a conceptual framework that discusses food security. And for a long time, food security have been, that definition, have been interpreted as embedding three dimensions: availability, local availability of food, local food prices, access, and often access means people income, people control of resources, leading to utilization, actual intake, consumption of food. Economists, consumption according to economists is a different thing than consumption according to nutritionists, another source of confusion. An economist consumes something if he has spent some resources on it. Even wasting food is a form of consumption in economics because you are paid for it. Whereas a nutritionist will always be very careful in distinguish between what is actually intake from what is probably wasted. So, availability, access, utilization. You read virtually every food security pamphlet, report, they will talk of this. But what is missing in this framework is actually the decision-making agent, the person who, given the local availability or the condition of the market, given their income and price, make the decisions on consumption. So I think that from a measurement point of view, in the past, there has been an attention of measuring availability of food, measuring food prices, measuring actual consumption, and sometimes measuring nutritional status of people, like with anthropometry measures. And for example, during the previous development agenda, the Millennium Development Goals, we had two indicators: the prevalence of undernourishment related to actual food consumption, even though undernourishment seems to be conveying the idea of a nutritional status, the indicator is actually not going there. And the prevalence of children underweight, which was the result also of nutritionists criticizing the prevalence of undernourishment and say we need something that is more directly measured rather than modeled with a statistical model that most people don't understand. And more recently, I think attention has, and when I say more recently, it's not that recent because it's already 40 years, that attention has also been placed to the people ability and freedom to make. So focusing on the individual, adding something that these days is recognized as another fundamental dimension of the food security problem, which is referred to sometimes as agency, that links all this framework together. And it's a shift also from country focus to household focus, and even more so from household to individual focus, which I believe it's a good progress. And this is, for example, important to highlight gender disparity, age-related problems, etc., etc. So today, this is from the high-level panel of experts on food security of the Committee on World Food Security. They have identified 6 dimensions in the process, in the definition, the 1996 definition of food security. And if we want to focus on this central part, what I find it very useful is a definition of food insecurity as the inability to acquire or consume an adequate quality or sufficient quantity of food in socially acceptable ways, or just even the uncertainty that one will be able to do so, which was put forward by Cafiero, researcher at Cornell University in 1992. And later on, I will tell you why this definition is so important. What we measure when we speak about when we measure food security, there are several. In this conceptual framework, we can focus on several aspects. We can measure food availability. This is done through exercises like food balance sheet, supply utilization account. This is something that the organization does commonly. I would say very little statistics is involved there. You just have to account. It's more an accounting exercise than any statistical inference. Food prices and incomes, I would say this is where perhaps still today most economists focus their attention. And everybody knows that in many concepts of poverty line, there has been always reference to food. So a poverty line, the basic essential need start from defining the minimum amount of food that people have to. So there is a long tradition of food involved in discussion on poverty line. On food consumption, on nutritional status, this is where nutritionists focus their attention. And one extant problem here is that measuring actual food consumption is awfully difficult because It's difficult to collect data in a timely manner. It's difficult to define what is the proper time horizon, because people like to change, to vary their food consumption. So there are many technical issues, and we will discuss some implication of these difficulties in measuring food consumption. But still, often the data that we have at our disposal is data on food consumption from dietary surveys, and so. And later, the last part is taking a very different perspective and defining food insecurity as a latent trait, food insecurity as an idea, food insecurity as a theoretical construct, very much like poverty. Because even though we want to attach some material connotation to this, these are social constructs. These are ideas that we invent because it is useful to discuss about inequalities in human societies through the lenses of some social construct. But as theoretical construct that raise the problem of, can we measure them? Does it make sense to even ask the question, I am measuring the something that allow me to classify a person as poor versus non-poor, food insecure versus food secure. So this is what we have in front of us when we approach the problem of food security assessment. Let me move to the second immediately consequential section in my talk, which is, okay, but what is measurement? What does it mean to draw statistical inference? Why do we need statistics if we want to measure things? And correct me if I'm wrong, and apologies if this seems to be a little bit simplistic, but I have the impression that most people, including professional researchers, have some superficial vision of what measurement means and what statistics is. In terms of measurement, it seems that many people believe that you attach numbers to objects, and in this way you are measuring something. So there is also being defined measurement as the process of assigning numeric values to units in a population following some rules, and that's it. And then also a simplistic view of statistics is like, okay, then I need to describe the distribution, location, spread of those values in the population. And this is what statistics does. But if we really want to use these devices of measurement and statistical analysis for scientific progress purposes, we need to be a little bit more sophisticated. So, yes, measurement is attaching numbers to objects, but this cannot be done in whatever way. First of all, the numbers that are attached to the object must represent the magnitude of a specific attribute of the object. So we don't measure an object, we always, or a subject, we always measure the magnitude of an attribute. So quantification is related to the quantity of individual units of a given reference are contained in the magnitude that we are studying. And the relationship between the numbers that are the digits that are produced by the measurement tool And the magnitude that I am revealing must be a one-to-one. There should be a one-to-one relationship so that only when I apply the tool, object of an attribute of a different magnitude, the number should change, and the number should change in the same direction and by the same proportion of the magnitude. And so, in order to conduct measurement, you always need to have a measurement tool, a protocol to which the measurement tool is applied object in order to capture the desired, and then, very important, a reference scale. A reference scale is the definition of this unit, this fundamental unit. Can be the meter, can be the liter, can be the volt, can be the ampere, can be whatever. In the physical science, we are very accustomed to defining those units. But in the social science, what are those units is awfully challenging. And for example, one of my criticisms of economic analysis is that a dollar is a unit relevant to establish measures. I don't know how to call it. Level of what is needed to classify poverty. So I'm very critical of monetary poverty because you're measuring something that is highly specific of a system that have decided to adopt a monetary system, but money metrics are not necessarily representing real human well-being. So as farther I would go in my training of seeing this welfare economics, studying things in terms of money metric welfare measures, I become less and less impressed by this. But the problem remains that then what it is and what do we do when we actually, it's very useful to speak about poverty, to do food insecurity assessment, to inform policy. So we need something. And so we need to be able to measure, because if you can present results that carry the rhetorical value of reliability, neutrality, objectivity, then these are very effective. Many people say you only manage what you can measure. If you cannot measure something, it's very difficult to understand whether you're making progress or not, so on and so forth. So we need measurement, and we need good measures. And good measures will have two properties. And the fundamental properties are validity, meaning that the numbers I'm producing are actually capturing the thing that I intend to capture. Seems obvious, not so obvious. And reliability, which is how well this one-to-one relationship is captured. And this is where statistics become essential. In science, for a long time, attributes that are not observable physical attributes has been disputed whether you can measure it or not. Nowadays, I think everybody agrees that almost everything we do when we measure something is at some point modeling something that we cannot observe and pretending that we have a good system that represents those attributes, the structure of these attributes. And I don't know if you have ever heard of Lewis Tversky. There is now a theory. Actually, some economists, Gerard Debreu and Yeah, Daniel Kahneman, you have heard of it. There is a theory in economics, it's called the prospect theory. This is essentially when this conjoint additive measurement theory has been put forward and is now a way of measuring things. Sorry, let's put it in a different way. This defining the characteristics that an attribute must have in order to be quantifiable. So it's the essence of quantification. And now, thanks to this conjoint additive measurement theory, we know that even unobservable theoretical constraints can be measured if a set of observable phenomena, pieces of information that are related to the latent trait, to the unobservable thing. If we can identify a set of those items, pieces of information that conform to the characteristic of a conjoint additive system, then we can measure, and we can measure with the same rigor of the measurement that we are normally exposed to in physics, in material hard sciences. Now, there are, however, still differences between applying this measurement concept in the natural world and applying it in the social, human behavioral world. And in the physical, biological, natural science realm, we normally study physical attribute, means that the act of measurement and the act of collecting information are one and the same. Imagine you do an agricultural survey in which you have to study the land size, parcel size. You go in the field with your instrument and you take a measure, and the data that you are collecting is the measure that you have taken. So the application of the measurement tool precedes the recording of the data. The data, the numerical data that you have, are in themselves measures of something. In the social science, actually the act of collecting information precedes the construction of the measure. And we have to first harvest information and then record them to make them usable. So we have data, but the data is not a measure of anything meaningful. The measure comes later when we process this data through an analytic process to verify and validate that those characteristics that ensure additive conjoint measurement are embedded into the measures, and then we have a measure. So the measurement in the social science starts after the data collection. And now, in this particular case, the problem of validity, are we measuring what we intend to measure, can only be addressed probabilistically. And so this is the key where statistics enter into the measurement process. And whereas it's true also in the physical measurement science, there is some statistics because you evaluate the extent of measurement error, you discuss of calibration and accuracy, precision of measures. You always have, however, a very clear distinction between the true measure and the measurement error, and the measurement error is normal. It's almost by definition, the very definition of the Gaussian normal distribution is This is the distribution of measurement errors. In fact, it's often is referred to as the distribution of the errors. But normal means zero mean, symmetric distribution. So reliability reduces to making sure that you have as small measurement error as possible. We will see that determining the measurement error in these models of latent rate measurement is much more complicated, and therefore often the problem is simply swept away and neglected. I ask those of you who nodded when I spoke of head count, I wonder how many have really paid attention to measurement errors in the variable that we're using to do the head count. And in the old time, some models, econometric regression model, used to present the problem of errors in the variable. These days, I don't see it anymore, not even mentioned. There is very, under the IID assumption or independence, yeah, but are we sure that the numbers that we are using as a measure of something are really without error? And what is the relationship between the error in the variable and the error in the regression? So just presenting this thing, then we can discuss more later. In the engineering, in the physical world, the constructing a measurement tool, defining a measure is relatively easy. You have a physical reference, the meter, the kilogram. And then what you have to try to do is, let's put it in, what I want to say is that you can use the measurement tool, read the digit without even bothering on how this tool works, because somebody else has done the dirty work for you. An engineer has created a thermometer, and nowadays you only do push a button and read a digit, and that's it. Measuring the temperature, But for us, it's much more difficult. If you don't understand how the measurement tool, which is an analytic model, is constructed, you risk to misuse and abuse the numbers because you don't understand exactly what the numbers mean. So this is to say everything is more complicated. So bottom line, measurement is possible. Measurement can be done in the proper scientific way that we are used to think about for sciences, also in social science, in human behavioral science. But to do it, it's more complicated. Now let's go to statistics. And statistics, together with probability theory, is strongly connected area of research, could be interpreted as a branch of applied mathematics. And sometimes you find that statistics is probability theory, is measures theory. Measures theory is a branch of mathematics. And however, in my view, such an interpretation would miss a very important distinction between what we call descriptive statistics and what is the process of statistical inference. And to me, statistical inference is the most interesting part, is the most important part. And whenever our ability to observe is limited, whether we know it or not, whether we admit, recognize it or not, wherever we make a decision, we are doing some statistical inference. So why don't let's study it formally so that we understand how we function as humans when we make decisions, because there is no decision made by human under perfect knowledge. Perfect knowledge is a myth. We always have to act not knowing everything in anticipation of some outcome. And in doing this, we are making a process of statistical inference. Sir Harold Jeffreys wrote a book in 1931 claiming that the only legitimate scientific inference is statistical inference. And then he also popularized and presented the Bayesian way of conducting statistical inference. And everything else that you could, and I know this is a strong statement, and I apologize in advance if I don't want to offend anybody, but I'm strongly agnostic, I'm not religious. I think that any other way in which we try to describe the human decision-making process different from a statistical inference process, it's either an ideology or a dogma or a religion, has nothing to do with science. So, we should keep thinking if we want to progress in science, never stop thinking and start believing things, because every belief can only be interpreted as my current prior distribution, but I should always be willing to modify it if new information comes about. If you have a degenerate prior, it's very difficult, or there is a name, I don't even remember what it is. Some prior are false because they cannot be modified. And these are dogmas, these are ideologies, these are religious creed. It's not part of science. And why I think in social science is so important to be able to use statistical inference in the correct way is because we can use it to avoid confusion between differences and inequalities. So, what characterizes the human society is that we live in a very diverse. There is much more diversity in the human species than in almost any other animal species, apart from those where humans have put their hand, messed up things like dogs, for example, creating aberrations by selection, but these are not. Whereas in the humans, there are differences. Yet, I think most of us believe that there is also a fundamental equality in the human society. We are all born equal. And so, how to reconcile this fundamental equality with the vast example of diversity? It's a challenge. And we would like to study differences, distributions, but to highlight inequality, not to detect differences. We should recognize difference, celebrate even differences, because difference is richness, but fighting inequalities. And so my main point in doing these talks, these lectures, thank you, Jesse, is that I think it's important because we can distinguish and not confound inequalities with differences. And this is challenging because understanding even that we are all equal is not so obvious. And lots of people make this confusion and start believing that because of some physical, cultural differences, we are not the same. I have yet to find one religion that is not founded on the distinction between us and them. And I think it's a problem. Now, if we don't study statistics, if we don't apply statistics correctly, we risk several things. And nowadays, this is becoming more and more dangerous because we are submerged by lots of data. And so the process of elaborating, processing this data to derive measures of relevant phenomena is very, very important. But however, one of the problems with big data is that we have too many data and too little metadata. We know the numbers, we are exposed to numbers, we know very little of how these numbers have been generated, under which condition, etc. There is too much data science these days. The computer allowed to process data quickly in black box kind of machines, and very little carefully thought statistical inference. And statistics is a life vest that will protect us, and we don't drown in this ocean of information. And another thing is that lots of data is presented in numerical form. We see numbers everywhere. But these numbers very often are just the labels put there, but they don't possess the characteristics that we want to have in numbers. And finally, very little attention is paid to the fact that those numbers are imprecise. And so there is always some measurement error around those numbers. So this is in terms of, I would say, a premise and motivation of why I encourage you to pay very careful attention to the study of statistical and statistical inference, and maybe open your mind to the problem of measurement. And so let me move now to the example that I want to make to show in practice what is that I mean. The first example is something that it occurred to me when I first was exposed to food security assessment and the prevalence of undernourishment. In 1974, an Indian statistician, P.V. Sukatme, in 1961, he published an article, was a reading at the Royal Society of Statistics in Oxford, in which he presented this idea that in order to make an assessment of how people are not eating enough, you have to recognize that some of the variability in food consumption is actually associated with variability in the requirement of food. If in a population people try to adjust their consumption to their requirement, eating more when they work harder, eating less when they are living the more, eating more during the winter, less during the summer, all these kind of things, then part of what you observe when you study a distribution of food consumption must be revealing an underlying problem, an underlying distribution of requirement. And so, if we want to, for example, partition our population between those who eat less than their requirement and those who eat more than their requirement, we cannot refer to the average requirement as a threshold. And so the methodology has been refined, has been slightly adjusted, but the essence of the method that was proposed by Sukatme is still what informs the prevalence of undernourishment. And however, I am now interpreting this as a more general class of problem. And so in many socioeconomic assessment. We assume that there is a measured outcome, a variable that we can characterize the distribution of, call it income, call it dietary energy consumption, that describe our population with reference to that attribute, and we want to study it. Call it wealth, call it food consumption, whatever. Typically, we find a way of characterizing this distribution, maybe empirically, maybe through a statistical model, and then we contrast with a fixed threshold, a cutoff point, call it poverty line, average food requirement, and this is a way in which we classify everything below the threshold, everything above the threshold. So formally, this is evaluating a distribution function or counting an index function, evaluating an index function given a threshold. So very easy. These are described as head count, cutoff point methods, prevalence estimate, because in the end we are estimating a proportion, no? Part of a population. And graphically, you can represent it like this. You have a distribution, a density function, and you have a cutoff, and then you evaluate an area underneath. Now, you need to justify why it is appropriate to use a fixed threshold. So a single number, a single value that is valid for every unit in the population. And normally, usually, typically, this is done on normative basis, saying, okay, apparently, no, all humans are equal, and therefore the poverty line is the same for everybody. The energy requirement is the same for everybody. It seems a way to recognize this fundamental equality that we want to respect. And this means that, however, everything that is in the distribution is inequality. Because otherwise, the population would collapse to a single value, and either a single value is above the threshold or below the threshold. And there can be no cases in which, if you see, sorry, let me put it there, if you see some diversity, that must be revealing inequalities. And sometimes there is some mentioning of the fact that, well, in reality, we recognize that these reference values, these thresholds, are not the same for every individual. We should consider some variability, but very often that's it, and say, despite of that, we take the average of this reference value and we use that as the threshold. The average energy requirement, the average poverty line. But in a way, this is like saying that from a probabilistic point of view, these two distributions, the distribution of the outcome that we observe and the distribution of the thresholds that we don't observe, are statistically independent. So that if you think in terms of bivariate distribution, I'm looking at your professor of statistics sometimes to make sure that if you have a bivariate distribution, like the marginal distributions are independent from each other. It doesn't matter where you cut the bivariate distribution, the marginal distribution of the other variable will be the same. And this is a strong requirement. What happens if this is not true? And examples abound, to the point that I think it's more difficult to find the exception to the fact that there always seems to be some statistical relationship between these two variables. For dietary energy intake is so obvious, for the thing that I mentioned before, that people try to adjust their consumption to their requirement. But for economic variables, this may be a little bit more subtle, but are still there. For example, imagine that the prices, which are a different thing than the quantities, no? The prices of essential goods and services that form the normative consumption basket that everybody should be entitled to, if the prices vary by location in a country, then how do you justify using a single poverty line for an entire country? No? What you could do, you should say, okay, I recognize this distribution of variability of prices spatially, and I, before characterizing my income distribution, I deflate the income values so that I make them equivalent to take into account this spatial correlation, spatial variability. And therefore, if you spatially deflate the income, you can use a single poverty line, the average poverty line, because deflating the local poverty line, all of them will collapse to the same point. But now this is the problem that I even try to inquire with our colleague who managed the poverty and inequality platform at the World Bank, asking in how many cases the distribution that you publish, that you report, are spatially deflated. And maybe in one or two cases they do a urban-rural deflation, but that's it. Justified with lack of data, they say we cannot do it because we don't have CPIs and prices that are representative of each location. So this is not done. And this is the practice. Lots of assessment are done using non-deflated distribution of income when, however, the prices and therefore the poverty lines should vary by location. In the nutrition part, in the dietary energy, this is actually so well recognized that nutrient adequacy assessment, which means assessing the adequacy of energy, protein, vitamins, etc., are done through a cutoff point method where the threshold is set to the expected average requirement in that population group. But Beaton, who was the one who introduced this model, and Rosalind Gibson, that has published the most widely used manual of nutrition assessment, are very clear that this expected average requirement cutoff method cannot be applied to energy requirement. It can be applied to protein, it can be applied to micronutrients, but not to energy, because the correlation between consumption, intake, and requirement is too strong and too evident for energy. And unfortunately, the correct solution that Sukatme presented in 1961 to this model has not been recognized. And when I am discussing the POU method with economists, I always say, no, but this is a different thing. This doesn't apply to poverty assessment. So the monetary poverty assessment and the undernourishment assessment are very different. So yes, now after 20 years, they have accepted that the POU has its merit, but they still see it as a very separate conceptual model from what they do. But I think that this is not true for the very likely possibility that price varies spatially in a way that is not independent of income. And so let me illustrate with this little chart why using the average, when in reality I should use different poverty lines in different population group, leads to a bias. So these are very simple distribution in which I'm imagining two groups, the green and the red. These are population groups. Among the green, distribution of income is a little bit skewed to the left. So these are the relatively poorer, and the red are the relatively richer. So in principle, I should have. Now, if there is a positive correlation, the threshold valid for the green income distribution should be on the left, and the threshold valid for the red distribution should be on the right. What happens if instead I use the average? And if I use the average, I make errors in the two groups that do not compensate, because the error that I make, the green dashed area, which is how much I'm overestimating poverty among the poor, is larger than the area that the red one, that is how much I'm underestimating poverty in the rich wealth group. So this is sufficient to say that if there is a positive correlation, rather than the average, I should use something that is lower than the average in order to make these green and red areas to be equivalent. And if instead there is a negative correlation, the opposite is true. So the green line should be to the right of the average, and the red line should be below the average, and I have the opposite result. So this is all to say that use of the average should be qualified only if you have proven absence of correlation between the reference threshold and the levels of income. I will stop here on this part. Let me move next to the other area, which is how do we measure latent train? I'm aware of the time, so you tell me. I'm looking at Jacine, and because if you want to stop, ask some question, and then continue. Yeah, probably this is a good moment to stop, ask some clarification question, have some discussion, and then we move to the next part. The next is the other example I wanted to make is why we need to use statistics in measuring things that we cannot observe. The lesson out of it is that we need to distinguish inequality from differences. And if there are differences in requirement, in the cost of living, in the conditions of where people live, we need to reflect them in our model. So let's stop and open the floor for the question.
Those online, may I request you to raise your hands if you have to make a comment or ask a question. Thank you.
And These moments are very embarrassing. If nobody asks question, I have two possible, thank you, inference that I can make. Either nobody understood anything of what I say and they don't bother, or everything is perfectly clear, no question, no doubt, which is even a probability zero event. So I don't believe it. It must be shyness. And thank you.
Thank you, sir. I have a two question actually. First is that why didn't you choose the conceptual category of poverty instead you chose this? Because I'm thinking that I've found that there are many common attributes between the poverty and the food insecurity. The food insecurity is also being created by the many aspect of discrimination. I'm thinking in terms of social discrimination, economic distribution, and cultural distribution discrimination. So why did you choose that? First question, and the second question that you made a very strong statement about that. Whenever we use other method instead of statistics by for measuring the human behavior, that is based on the religion or dogma or something like that. So what I am understanding statics measurement is that we are trying to capture human behavior as a static in nature, as a fixed state. Like in a fixed state, like measuring something to measure something. How I am understanding, maybe my understanding is
Now, maybe in my language, my ability to speak, I never use the word static. Never. If you heard static is because I misspelled, I mean statistics.
I'm 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 saying, am I audible? I'm saying that the the measurement that you're talking about, statistics, you said that statistics, the other method of measuring other than the statistics measurement is based on the dogma or religion or other
Statistical inference.
inference.
I was making that commentary when I was presenting and discussing the process of statistical inference. It is related to drawing conclusions to inform decision. So it's not the measurement part. I know this is confusing because I am carrying over two things at the same time. This probably should have been a whole course in which we dedicated one lecture to one thing and one, but to clarify.
Maybe then you can clarify the
Yes, no.
difference between this, and
Thank
then
you.
I can ask my question for you.
So
Yeah, okay, thank you.
your second aspect is I am describing any process, mental process, behavioral process of a human as making a decision. And this decision is based on a set of information, which has been accumulated for the entire life up until that point. And I am saying that information is by necessity incomplete, partial. Also because most relevant decision involve the future. If I do something now, is because of what I anticipate, what I expect to happen tomorrow, in 1 hour, in 1 year, no? So these are always decisions made with a prospect in incomplete information because nobody knows what can happen. So the fundamental characteristic is uncertainty. And when I say whether we admit, recognize, know it or not, all our decisions can be described as a process of statistical inference. What does it mean and why this is different from actions based on dogmas, ideologies, is that you recognize the presence of uncertainty. You know, in a deep sense, that there are things that you don't know. And therefore, you act in a context of what I call statistical inquiry. The alternative is that there are things that truly you don't know as a human, but you pretend that you know. And this substituting the ignorance, the unknowing with knowledge, which is false knowledge, is what I call ideology, dogma, religion. Is the credo, is the belief, is the things that I accept even though I don't know. And according to some philosophy and religion, you can even never know, because these are beyond the human ability to acquire. So this is what I was saying. Regarding your first question, I'm actually trying to drive the close parallels between the concept of poverty and the concept of food insecurity, claiming that these are both mental constructions, ideas. And I am actually opposing narrow vision that wants to, for example, reduce food insecurity to dietary energy intake, to calories. The problem of food insecurity as a problem of humans not having enough food. I think food insecurity is more than that. And the way in which we should look at the food problem is way more than mere food availability or actual dietary energy consumption. Because if that was the problem, it would be enough to already we produce, the planet Earth produces enough food to feed many more people of that currently live on the planet. So if it was a matter of food availability and energy consumption, there was no food insecurity problem. So the problem must have to do with violation of other things that are the means in which people access to food, the means, the possibility, the freedom of people to make their choices regarding food. And I find it also equally limiting the vision of poverty as monetary poverty. So everybody that reduces poverty assessment to measuring monetary income and classifying would be mistakenly reducing the problem of poverty to something that seems apparently measurable and dealing as if it was just a arithmetic, I don't know, accounting kind of thing. There are many things hidden behind a vision of monetary poverty that understanding it would reveal it, and we need something else.
Thank you. Online, we have Ugochi. Ugochi, please unmute and ask your question.
Also, Maria.
Yeah, after Ugochi, it will be Maria.
Thank you, Professor, and good morning, everyone. Please, I wanted to find out, like when you did something on your problem statement, initially I was going to ask how you were able to operationalize the term poor and the poverty line. We know there has been, is it a poverty line, analysis or something that has been put up, but how did you get the threshold? And looking at the poverty, talking about the poverty line, then we talk about food requirements, and we classify them into the population that is relevant, and into classes or categories, the poor and the non-poor. My question happens to be, how do we classify poor? Who falls under poor and not and non-poor, those who are nourished and who are not nourished and overnourished, undernourished. How do we categorize them, or how do we operationalize the nourished and undernourished and overnourished? Since looking at the problem statement, we're not looking at those who are talking about income or wealth. So how were we able to solve this issue with the poor, non-poor, and undernourished and overnourished? How do we classify them and operationalize the terms, please? Thank you.
Thank you, Ugochi. Would you like to take the next question and then respond, or you won't?
Let's try. If it's
Okay, Maria.
related, might be easier. If it's not related, might be more complicated. But
We'll try.
we'll try.
Maria, please.
Yeah, well, thank you very much for the lecture. It has been very interesting so far. I wanted to ask you about the politics of the data. In the last decade or so, there's a revolution of data everywhere. And I was wondering why. I mean, it seems like when, in regards to poverty or food insecurity, there is institutions and states are lagging behind. And I wonder if this is a problem of science, is a problem of political will, is a problem of economy of creating this data, which is more sophisticated, or why it is happening. This is the first question. And the second one is do you think for this kind of studies, I mean, there's in social sciences an important move now to mix methods. And in which regard do you think qualitative methods can also supplement the statistics analysis, or what are the limits of these studies? Thank you.
So it's not related, but I can even try to relate them. Let's, Ugochi, I made this presentation presenting what is the essence of an analytic problem framed in terms of a distribution and a threshold. Now, you are, if I understand correctly, going beyond this and say, okay, but what do you mean exactly by wealth, by income? And how do you determine this vertical line that you call poverty line? Or this may be a distribution of dietary energy consumption, caloric consumption, and how do you determine the threshold? So you are correct. These are not simple questions, and you may find people who have different conception of what should be that I observe when I study poverty. So monetary poverty is only one way of looking at the problem. There is also the concept of multidimensional deprivation, poverty related to capabilities rather than outcomes. So there are many different theories, and I'm not a professor of, I don't know if you can say poverty, but it's part of, normally this kind of thing are taught in economics, and I think that it's more of an issue of sociology, of, I don't know. I think there should be a unity of all human and social sciences, but I'm not entering into that. I'm only making my own personal reservations against monetary poverty. But the point I wanted to make here is purely analytic on whatever you have characterized. If you contrast a distribution with a fixed point, you have to be very careful in making sure that there is no correlation, covariance, there is no association in a statistical sense between these two variables. We can discuss, my expertise would be more in terms of energy consumption, food consumption. So if it's interesting, I can spend some time describing how the dietary energy requirement is determined, what are the characteristics. but I wasn't planning of spending our time in this lecture on that. So maybe, Ugochi, you can send me questions. I will leave my email address. I think you have it already. And I might respond on specific curiosity question on how we compute those thresholds and how we characterize this distribution. The point here was very simple, if you want, to denounce that head count method, if used in a too simplistic way, may lead to biased conclusion, incorrect conclusion, other than in very special cases. So look more carefully when it will happen to you, if you are asked to apply such a method, to try and understand whether you can exclude a correlation, or if you cannot exclude a correlation, if it's a positive correlation, it's a negative correlation, because the result of your analysis will be conditioned. Maria, I am all in favor of mixed method approach. I am a strong believer of the unity of science. I don't make a big difference between qualitative research and quantitative research, because I believe that, as I said, every decision we make can be interpreted as the result of a statistical inference process, which means that even a qualitative researcher that does some purposive sample, conduct some interview, collect this material and do some coding of the elements, the themes that have emerged, and then report by making a summary and by drawing conclusions, I could describe it exactly conceptually as a process of gathering information, processing them, drawing conclusions. And that's science. So I don't make this difference. Unfortunately, I have heard in the past few days we had a workshop here in India, young students like you saying, if I want to get a job, I have to study statistics. Nowadays, data science is so popular, so if you are a good data, if you can crunch numbers, it's easier to get a job. Most of it is unfortunate because it's based on the false impression that only because you present something numerically, quantitatively, it's more credible, it's more reliable, it's better. Actually, what I'm doing today is to reveal the risk that by using quantitative methods in a superficial way, rather than being approximately right, you end up being precisely wrong. And big data doesn't solve the fundamental problem of knowledge. Technology is the reason why we are here, is the information and communication technology that has made much more information available and sometimes even driven to people even if we don't ask for it, no? Information reaches us and makes us, this is what I described as an ocean of data in which we have to swim. But if we don't want to drown, let's start understanding how to make decisions. So how to interpret, how to process information. So absolutely, try to keep a mix of humanities, as they used to be called. I keep saying human behavior and social sciences. I'm benefiting a lot as an analyst from studies of anthropologists, from reading history. Those kind of things are way more powerful than learning how to crunch number using Python or R or Excel. However, sometimes to land a job, you need to put the knowledge of a computer software into your curriculum. I hope I answered. I see Silvana has her hand raised.
Silvana, do you have a question or a comment to make? Silvana, please go ahead, unmute and ask your question.
Silvana, we don't hear you. Maybe you're muted or?
No, Silvana is in a location where her internet is not necessarily good. So that could be a possibility. Let's give her a few seconds and then maybe you can add it to the chat. You can add your.
She was reconnecting, I think.
Sorry, I got disconnected, but I'm back here. So, yes, I have a question regarding the new methods that are being used in measurement, not only in poverty, but also in inequality. So I would like to know how this machine learning, I'm talking about machine learning, in regarding a multidimensional poverty index. Now this is being proposed to select the dimensions in a non-arbitrary way, right? And for example, in inequality of opportunities, Francisco Ferreira has been doing and applying this because they say, okay, we have been a little bit arbitrary in selecting which indicators or dimensions should be there. So I would like to know how machine learning is coming into play in this methodological proposal, because what I have understood from machine learning methods like this forestries, these random, all these things, is that they get away a little bit from all these assumptions that we have learned in econometrics. So the basic assumptions of the linear models, we just forget about them in machine learning. So what do you think about this, and how is this coming into play in this methodological proposal? Thank you.
Thank you, Silvana. I am not keeping myself up to speed with the potential innovation of applying machine learning method, data science method to all the problems. The only thing I can tell you is that there is no fundamental qualitative innovation in that, other than exploiting the machine's ability to process much more data in an automatic way without an intervention of a decision maker. But I am doubtful that those tools per se may solve fundamental problems. Now, with the multidimensional poverty index, and I know that I probably say something that would be shocking to this group of people because of a series of connections that have been made in the history of poverty assessment, that multidimensional poverty is seen as a operationalization of the capability approach. And Sabine Alcair has been a student of Amartya Sen, and the work on the multidimensional poverty index has been guided by Ferrer and Alcair. I have one fundamental problem that is still there, which is that this idea of not daring to make a decision, to take the responsibility of deciding of the many forms that material deprivation can take, which is more important, which is more relevant, which is the thing that we should look at, is a problem. And the way in which, and now I speak professionally from my point of view of quantitative analyst, I have read way too many times that assigning equal weight to each dimension and assigning equal weight to each indicator within a given dimension is a supposedly neutral way of doing it. Not at all. It's probably one of the worst deliberate decisions to give equal weight to things that may be completely different. And also, there is no recognition that you may have within one dimension of the multidimensional poverty matrix 3 indicators that may be correlated, that may be partly redundant. Giving equal weight to 3 redundant indicators implies that you are tripling the relevance of that particular single thing, and it's a mistake. So I don't think it's machine learning that addresses the problem of how can I detect what is truly relevant when I analyze a complex phenomenon. The issues that you have to address are, one, from a normative point of view, from a political point of view, from a substantive point of view of the phenomena, the social phenomena that you are studying, what is truly relevant, what is more important, and you should, the analyst, the researcher should take the responsibility of making that decision. To me, food deprivation in this context is more important, has priority, needs to be addressed first before, I don't know, transport or education. And it's a responsibility that no matter what, the policymaker in the end will make. And so if we want to inform policy, we should suggest to give more emphasis to something, less emphasis to other, and being clear about that without hiding behind the veil of, no, it's the machine that chose. Because what the machine can do is only either analyze frequency and do something proportional to some numbers that somehow are there. So this is what I say, we have too many data, too little metadata, and especially too little thinking about it. And then from the purely numerical point of view, if I have various indicators that are related to a common phenomena that I want to capture, I want to measure, the next part of the lecture will go exactly into that. We will be discussing now, I will be presenting you the Rush model, which can be interpreted precisely as a solution to the problem. How do I assign weights to binary indicators to compute a composite index that is meaningful? Not only meaningful, but is a composite index that is a numeric value that possesses the characteristic of quantity. So it's something that I can use to compute averages, to calculate differences, to rank. So it's exactly, this is why I am so happy to present this. I think this is the real innovation in the last. Rush model was introduced in 1960, sorry, 1980. It's a long time too, but nowadays it's being used in many areas But it is, to me, the fundamental innovation in social measurement. It's not from a quantitative multivariate analysis point of view, is nothing particularly sophisticated, but conceptually, it addresses exactly the problem. How do we combine pieces of information in order to filter from those distinct pieces of information, different indicators, what is relevant and what is not? How do I filter the signal from the noise? Where the signal is something that is socially relevant, is the food insecurity, can be poverty. By the way, I am aware of some studies that are applying Rush model to indicators of material deprivation. So essentially, the same data that is collected when a multidimensional poverty assessment is planned, is designed, those same data can be analyzed with the Rush model and come up with a different way of combining them. I have to say, and I will immediately go home, read whether or not underneath some of these machine learning applications that you are mentioning, there might be actually hidden the Rush model in a different form. I don't exclude it, maybe the case. So let's go there, if you allow me. And let's talk of the Rush model. Again, what is the premise to all this is that we want to measure something that we can never observe because this is an invention, is a product of the human creativity. The Rush model provides the basis to do it in a way that the resulting measure possesses, in a statistical sense, in a probabilistic sense, the characteristic of conjoint additive measurement. What the model does is that if we want, it's like this, if we want to respect those property of the measurement, invariance, the fact that it doesn't matter what I am measuring, the way that my measuring system works doesn't change. That is that conceptually imposing the restriction of the Rush model into the analysis is the same motivation that you never see a metric ruler made of rubber. One fundamental characteristic of metric ruler, they should be rigid. They should not stretch nor squeeze. They should not be affected by other things like temperatures. It would be very strange if I measure something and my ruler stretches because this object is warm, and then it shrinks when I measure something because that object is cold. So the Rush model is that the rigidity that I put in my metric ruler. Conditions that ensure that the way the measurement system works is not affected, and the digits that I read are only the consequence of the magnitude of the attribute that I'm measuring. And these are technically, now, of course, I hope that this is just an opening for your research, and then you will go and read the book. You will hear of conditional independence, equal discrimination, and you will study the property of invariance of the measurement. So what is the Rush model? It's a simple probabilistic statement. In this equation, you recognize a logistic function. The logistic function has as argument a difference, a distance, a minus b. And now, what are these symbols? In this formula, x, I, j is my data, is the things that I have gone to the field, I have collected, I have coded and recorded. A and B are measures of something defined on a quantitative scale that represents the thing I am interested in. So, for sake of convenience, let's call this food insecurity. Imagine a single axis, one extreme, food secure, increasing severity of the food insecurity, so that you go from food secure to mild food insecurity, moderate food insecurity, severe food insecurity, all the way to dying out of starvation, if you wish. So it's in principle a real line, and we want to define those measures, numbers, real numbers, A and B, on this scale. What the Rush model says, that the probability that my observation is 1, and apologies, I forgot to say that in this formulation, x is a binary variable. It's either 0 or 1, yes or no, true or false, correct, incorrect. It's a binary variable. By definition, by convention in the food insecurity measurement, this is a yes or a no given to a question that you ask in a survey. 1 means yes, 0 means no. What is how this data is generated? You ask this question. What is the question? The question is probing whether or not a certain condition has manifested. The FIES, the Food Insecurity Experience Scale, which is the tool that we are promoting, for example, asks, during the last 12 months, was there ever a time when, due to lack of money or other resources, you had to skip a meal? And the answer is yes or no. What's the idea? The idea is that the question refers to a condition that is typical of a food insecurity situation. Only people who, in our conceptualization, are somehow food insecure might find themselves in a situation in which they had to skip a meal. They had to eat less. They had to get a limited variety of food. They had to go for an entire day without eating, and so on and so forth. So each question generates a response. By the way, I often will refer to questions as items. This Rush model is also interpreted as one form of item response theory. It's a psychometrics, the equivalent of econometrics in the psychology field, is the discipline that where item response theory is more often used. So we have this data. The response given to an item. The response given by a subject to one of the items of a scale. So we have 2 dimensions, and these are the index I and J. AI is what I'm ultimately interested in. Is the respondent, the person that I'm interviewing, the household that I'm visiting, where is this household located on the scale? That's my A I number. My final objective will be to get that number. What is Bj? Bj is the location on the same scale of severity of the item. What does it mean to skip a meal? What does it mean to go for an entire day without eating? What does it mean to eat a limited amount of food? Each of these conditions may be representative of different levels of severity of the food insecurity experience. So the numbers are A, the severity of the respondent, B, the severity of item. I go in the field, ask item J to respondent I, and I record the datum IJ. The response that respondent I gives to item J. The Rush model makes strong restriction in probabilistic terms. The probability that you receive yes as an answer is a logistic function of the distance between the position, the location of the respondent, and the location of the item. The logistic function, I think you know how it is. It's a monotonic increasing function bounded by 0 below 1. It's a damn useful model for a probability, and it's monotonically increasing. So essentially, this is what the Rush model is telling, is that if you ask somebody who's located, let's say, rather on the severe end of the food insecurity scale, you ask a question that is located rather in the middle of the range. I'm depicting a logistic function centered where A equal B. So everything on the right means that A minus B is a positive number. Everything to the left means that A minus B is a negative number. So now I ask somebody who is a very food insecure person, an item that is in the middle. What the Rush model predicts is that the probability of receiving yes as an answer is very high. It's very likely that I interview a food insecure person and I ask, did it happen that you cannot afford healthy and nutritious food? And the answer is, the models say you should expect a positive answer. Yes, it happened to me. If you do the opposite, you ask somebody like me, overpaid professional in an international organization, if I skip meals is not because of inability to manage resources, it's, you ask me, did this ever happen that you had to skip meals? The answer is no. Why? Because I am on the extreme low severity level of the scale. So that's what the Rush model says. And so let's stop for a moment and think, because if we disagree that this is a reasonable assumption to make, we cannot use the Rush model. But on the other hand, this is the only assumption that we need to make. There is nothing else hidden. So if we believe that it's reasonable to model the probability of receiving an affirmative answer as a function, as a logistic function of the distance on the measured latent characteristic, then we can use the Rush model confidently. Now, we form a scale means that we use more than one item in order to try to scan a range of values. So A Rush model questionnaire may be made of different items. These items are located at different position, means that they are trying to reveal situations that correspond to different severities, some milder, some more severe. The more item I have, the better, because I will be able to discriminate more. The more widespread the item are there, in principle are better because I can hope to create a measurement tool that applies to different situations. There is a trade-off that if I start asking irrelevant questions to some people, I'm wasting time, I'm wasting survey time, resources. So there is a careful consideration to be made of which item I apply in which context. If I'm in a relatively wealthy, affluent group, maybe I don't even need to ask the more severe question because I already know that the answer will be no. And the contrary, if I'm in a very disadvantaged population group, I might skip the least severe item because I know for sure that the answer will be yes. So, but having said that, what we do, we ask the same person all these questions. And the model is predicting what the answer. So, for example, an individual located there will probably say yes to item number 1, no to item numbers 2 and number 3. The model is telling me the expected probability is greater than 50% for item 1 because the item 1 is on the left. Below 50%, less than 50% for the items that are on the right. So this is how I represent it. Imagine that you have asked the person 8 items. If the person is there and you had to do this modeling exercise, what would I expect if I ask this person questions that refer to conditions that are less severe? I anticipate, I expect, I predict that the answer will be yes. If I ask those other questions, I anticipate, predict that the answer will be no. But this would be the easy life of knowing where the person is, which I don't. So the process that we do is a statistical inference on something that is never observed based on what you observe. You only observe the responses. You only have the data. You have collected the data. And this is the statistical inferential process. By the way, technically is a trivial exercise of maximum likelihood estimation. Because you have the probability of each data point, you can form the likelihood function, you can maximize the likelihood function using A and B as parameters. I'm speaking language that they are aware of, right? So, now, if you observe this data, what you think in terms of the position of the respondent? Can a respondent be here? Is it likely that a respondent located there would give those answers? Nobody dares to say yes, nobody dares to say no. Please do, because this helps me. Can a person be there? Yes, of course it may happen because things happen, but is the most likely possibility finally somebody nodding? No. Why not? No, back. The gentleman on your back.
You started with the thing that, you expect the person to be there, how would they with thought.
If the person was there, how do I justify that he has said no to all many questions that are on your left, on his right? Well, it depends on how we look at it. No? So there are a bunch of answers that must be considered very strange if indeed the person was there. So you do this reasoning and you should conclude that of the many positions in which this person might be, a position right there is the most likely. That's maximum likelihood estimation. Of the many values that the parameter can take, you choose as your estimate the one that maximizes the likelihood, the one that makes this pattern of response the one with a high probability of occurrence, given the model. Okay? So, this is it. This is how the Rush model works. And if you think about it, it's very simple. It's not complicated at all. And there is only one assumption, that everything depends on this distance. So the first assumption is that we are measuring something that makes sense to measure in quantitative terms on a scale, on a numeric scale, real numbers. And distances are meaningful. Distances are what determine the probability of observing a certain event. And then we can do lots of things with this simple model, because given a sample of data collected, we can estimate the parameters of the Rush model. We have a number of parameter A and a number of parameter B. We are approaching the 2 hours. I don't know if we need to stop, but let me just now go to the final conclusion. I have a set of other slides that I will skip. One thing that I want to highlight is that there is something that often is perceived as a magic result, that in the end, if I ask my questions to 10,000 individuals, or 20,000 individuals, or 30,000 individuals, my ability to discriminate is bounded by how many items I'm using. If I have 8 items like the fears, my ability would be to discriminate between 9 groups. Even if I have a survey of 80,000 people, I can only discriminate between 8 groups. Based on what? Based on what is called the raw score, which is the simple sum of affirmative answers. So this slide here was to illustrate that. Imagine that you have 2 respondents. Both of them have responded yes to 5 questions. However, not to the same question. And the result of the Rush model that appears to be strange is they will have the same estimated A parameter. The severity parameter is determined by the number of responses, not by which item have been responded affirmatively, which seems strange. How can it be that it doesn't matter? But then the explanation is, in principle, in this example, imagine that the items have been already sorted in terms of severity. The first one is fully consistent with the theory. The number 6 is not, fully consistent because there are two responses that are unexpected. If the person is there, I wouldn't expect no to the fourth question, and I wouldn't expect yes to the question Q5. So these are strange. But this is part of recognizing the statistical nature. Measurement error may happen, and the only difference between respondent number 1 and respondent number 6 is that I would be more confident that I am right in locating that person there, and a little bit less confident on person number 6. But there is no reason to make a different inference. Technically, this result is one of the best examples I have of a sufficient statistic. In the Rush model, the raw score is a sufficient statistics for the severity parameter of the respondent. You don't need to know which question have been asked. You can make your assessment based on the number of questions. But knowing which question have been asked and doing the process is very important, because how many of these unexpected responses you have in a given data set is the way in which you answer the validity question. If I am capturing an underlying latent trait, and the only reason why I observe this response, or the main reason why I observe this response, is because the model is capturing what I call food insecurity, poverty, whatever it would be, then those errors should be few, small. I would have very low unexpected response that are very far away from my estimated parameter. If something like that happens, either the model is wrong or there's been a coding error, and that variable was actually, like, for example, in the last line, I see a no in the third place for somebody with a raw score of 6. Those things should be rare. Second, look at each column. For each item, I should have relatively few unexpected response. If I have too many, I have to question that that item is actually contributing to measuring the same latent trait that all the other questions are capturing. So maybe I'm asking a question that doesn't belong to the measurement scale. So this process is the process of validation statistically, means that once you have estimated the model, you can compute the discrepancies, the error, the residuals, and you can evaluate the residuals, and you can actually compute statistical tests based on this residual, the difference between the predicted response given the estimated parameter and the actual response. This is the second line. Now imagine my model predicts a high probability of yes answers, means 1, and the actual answer is yes. 1 minus a number very close to 1, small error. If my model predicts yes, and I observe no, the difference is very large, big error. No? So this is a good way of computing error. You can create statistics based on this, how intense are these, how big are these errors, and so you can measure fit of your response dataset with the restriction imposed by the model. In order to claim validity, you have to have a closed fit. You can do it separately, item by item, and some item might be fitting so badly that you better exclude them. Pretend that you haven't collected. They don't belong to a Rush consistent measurement scale. Okay, well, I think I stop here because we are 6 o'clock, and but I wanted to present this model suggesting that you can look at it very carefully every time in which you have this problem. I want to measure something that I only know being related to things that I observe. Going back to Ugochi's question, I think, oh no, there was the Silvana question, multidimensional poverty. Multidimensional poverty index. I have signals of deprivation on various things. Maybe this is the way in which, depending on which deprivation have been reported by a certain household, I can identify in a population who is more deprived and who is less deprived in a quantitative manner. And I can decide, because in the end, the result will be that these numbers AI, the severity, the position on the scale, is a linear function is a weighted sum of all the items. And this model generates automatically which are the weights to be used attached to each item. So that if items are clustered together, they represent the same severity level, they will probably be receiving less weight than an item that is far distant, representing a very typical or special, peculiar deprivation. So the Rush model can be used to generate a composite index using a set of binary information in a theoretically robust way, in a way that the index that you obtain will be a valid measurement on an interval scale. The only thing is it's an interval scale. There is no meaning in what zero means. You can set arbitrarily the origin and the metric and the unit on this scale as you wish. Internally, for the ranking of the cases that you have identified, it doesn't matter because, again, it only matters the relative position. But if you develop a method like this and you want to apply it internationally in different communities, then at a certain point, people want to compare. And so there is a need of defining a reference scale. And this can be done by, in different ways, FAO collecting FIS data in 150 different countries, have been able to analyze the distribution of the severity of these items, standardize them, and deciding a reference scale. And now we can measure fears, collect fears data, compute fears measure, calibrate them against the reference scale, and compute prevalence of moderate food insecurity, severe food insecurity, in ways that are comparable across countries. And that's why it has become an SDG indicator, because comparability is a very important feature in the context of international assessment. I stop here, and apologies, I took longer than I expected because we wanted to have some time for question at the end, but
Thank you, Carlo. We are opening the floor for questions. Meaning we can't go on and on. So may I request those who have not asked a question to ask, so we'll give them a chance. And then there is an upper limit for the time. Let's say 15 minutes from now is the upper limit. We can finish before that, for 15 minutes. Yeah. Thank you. Nikita.
Thank you so much, Professor, for the presentation. It was really good. I have two questions. First question is, I'm wondering about how we calculate the measurement of average per capita calories intake consumption. Like in India, Alag committee proposed this 2400 calories for the rural one and 2100 calories per day consumption for the urban one. So I'm just wonder how we calculated this. And my second question is like, uh, as we talked about the food insecurity. So food security also play a very important role, like the wastage of food. Food wastage index. I'm talking about food wastage index.
Food waste.
Yeah.
And you are linking food waste to food security.
Yeah, because somehow like if there is food wastage, like food wastage do inculcate to the like reducing the availability of food, and second the inflation in food of food. So as UNEP do publish this food wastage index.
Very clear.
Yeah, so can you comment on that? That's all.
Shall I address them?
Yes,
So,
please.
first question, the human dietary energy requirement is computed by nutritionists based on a simple concept that the human body requires energy to function, and there is something that is called the basic metabolic rate, that you imagine a human body in a complete state of rest, only to functioning for the vital breathing and normal, then there will be a certain amount of calories, energy that needs to be provided. So the resting live body of a human burns energy at a certain rate that is proportional to the body mass. So per each kilogram of body mass, you can say how much energy is required in a state of perfect rest. Then it is recognized that physical activity level also inflates energy burning. If you exercise, if you run, you will burn more energy. So in essence, to compute what is the actual dietary energy requirement of an individual, you need to know body mass and physical activity level. There are some specificity by gender, and so people also include difference by male and female and by age. So in the end, if you know the sex, age, body mass, and physical activity level, you can calculate the energy requirement. And there are formulas that have been put forward. There is a book of in 1991 by James and Schofield that presents those formulas. There has been a UN, WHO, and UNU, United Nations University expert consultation in 2001, in which lots of nutritionists have convened for several days, and they have confirmed those equations. I have come to understand that there is some discussion in India that the basic metabolic rate that is used in that thing might not apply to the Indian people, which I find it very strange, because I don't think that for whatever reason why Indian population should be fundamentally different in their physiological way of burning energy. So I know that there is some discussion, but I don't think this is a valid one. The computing energy requirement is very simple. Your second question was about, yeah, and on that, you made a statement. You said food waste reduces food availability. I disagree. Food waste cannot reduce food availability. If there is no food availability, there cannot be waste. If food is wasted, means that that food was available. The real question is available to whom, accessible to whom. And so there is, if there is food waste, I make a distinction between food losses and food waste. So there is a loss of potential food because there are technological problem in production, harvesting, etc., etc. But I'm not calling this food waste. I'm calling it food loss. If we are speaking of food waste, the only reason why there is food waste is because food is too cheap for somebody that can afford to spend money, get the food, and then waste it.
Yeah, my point was about
Food loss.
food loss.
Then food loss is a fundamental thing to analyze, understand, and reduce, because yes, food losses reduce food availability given the amount of resources that have invested. And I think that FAO is creating a food loss index based on actually with Indian consultant, referring to the work done here on computing food loss. It's not easy, it's very data demanding because you have to explore the entire value chain. It's not only at the production level, it's mostly a technological and logistic kind of problem. It's whether or not people can afford to have harvesting machines that don't lose grains, is whether or not you have storage facility that permit storing the food, etc., etc. But losses is in terms of the commodities, the primary commodity. Waste can be, and very frequently is, of food that has been already prepared, ready for consumption, and not yet been consumed. But that has nothing to do with availability.
Any other questions, comments? 1 minute, Pratibha. Online, somebody who's not asked a question made a comment. Anybody online?
If not,
If not,
let's
yeah. If not,
move
then
on
we give
to-
a chance
what's
to
your name?
Pratibha.
Pratibha.
Written.
Pratibha. Yes.
Pratibha, go ahead.
Yeah, thank you. So I have a very small clarificatory question that the model that you suggested in which while collecting the quantitative data, I was thinking that based on the individual perception and cognitive biasness, which differ person to person. While what question we are asking and what in return as you said, in return we expect certain answers, but that certain answer can be different from our expectation. So in the and just let me complete.
Only
And also,
elaborating the
and
answer.
also, I was thinking that on the basis, what question they are asking on the basis of individual perception and cognitive biases, their understanding of question could be their own, and on the basis of that understanding, they can respond differently. How to ensure the validity of their answer and how to ensure that whether on which side we should put that answer.
Excellent question. Thank you for asking it, because this is the things that people have more difficult understanding and most common misconception that these tools is perception based, is subjective, and so there may be an issue of arbitrarity of interpreting the question. I have to go back to showing when we analyze the data. Probably I should have done this. When we analyze the data, we process the information contained in the data in two ways. The first is I look at our sample and try to see what this group of people, whatever their culture, perception, condition is, what they are telling me regarding the item. So I'm using the information provided by the people to determine which item is more severe, which item is less, corresponds to a less severe for this group of people. So yes, this is a result that is valid for this group of people. But then what I do, I look up across the sample and I take the average, the prevailing response. Technically, what I do, I analyze the answer and I calculate the percentage of affirmative answer. How many people are saying yes to this question by question. Based on this, I make an inference. I say, if the Rush model is true, by definition, the more severe answer, the more severe item must be reported by less people. And the less severe item must be reported by most people. In looking at the distribution, sorry, I need to go back and forth, of this item, by construction and the structure, each of these item response function is a logistic parallel displacement, means that if an item is responded yes by most people, it is the least severe. There is a one-to-one relation between the severity of the item, the position of the item on the scale, and the percentage of people who respond. So I do, this is the first step, and I may need, moving, this is the data I have collected. Question number 1, 2, 3, 4, 5, 6, 7, and 8 is how they have been asked. There is no presumption on what is their order of severity. I don't know. I want the data to reveal it. So the first result is I calculate the percentage of yes answer, and I discover, for example, that more people have said yes to question number 3 than to question number 4. So in terms of severity, question number 3 should come first before question number 2. Sorry, I said 4, I meant 2. And the same for 5 and 6. So first, I am fully relying on the information provided by the respondent to order this question. This means that if I ask the same literal question in 2 different population groups that maybe have different cultures, different food habits, I can have different order. And this is one misconception, that a lot of people believe that the order of severity is known in advance, and so that you expect an item to be located there. No, it's a result. Okay. Second is these things that we discussed, saying in the end, there may be unexpected response. These are measurement errors. These are the things that I want to filter out from the measure. So if it were true that the reason why people answer to a certain question is strongly conditioned by their individual perception, and these individual perceptions are different in the group, I will have many unexpected responses, because many people will be different from the average. So this is the fundamental result, that if I perform the statistical validation of the model and I conclude for valid items and high reliability, means by definition that any influence of subjective perception-based element that certainly will condition the answer are relatively unimportant. They will be put in the errors, in the residual. It's like I'm estimating a linear regression, I compute the R square, my R square is 0.95. Means that overall, 95% of the variability in the data is captured by my model. We have a very similar reliability coefficient, Rush reliability coefficient, which has the same interpretation. We suggest that if the Rush reliability parameter is less than 70%, it's dangerous. Because those elements that can be subjective, can be perception-based, might be large enough to condition our answer. But the response to the criticism that these are perception-based subjective scale is everything that is subjective, everything that is perception-based, and everything that is accidental. Things may happen because the enumerator made a mistake in reading out the question, or language was used in a way that different people understood the same question in different ways. All these things will be picked up in the analysis. So there is an internal built-in guarantee that if your data pass the Rush test, you have a scale that is objectively capturing a quantitative latent construct.
Thank you. Thank you, Carlo. I am kind of coming in to stop a very interesting discussion, but also we are stopping at a moment where there's so much to think about and there's a lot to read and come back. Yeah.
But
So-
let me put on the screen probably the most important information that I am giving you today. My email address. Send question. Identify yourself. I was sitting in that classroom in Delhi on October 8th, and you will receive an answer. If not, call Vaishali and she will make it sure that I respond.
So on your behalf, I would like to thank Carlo for this very interesting and intense lecture. Can we give him a hand? Yeah, with this, we close today's session. Thank you so much. We have Carlo's email. We have lots to read and then get back to him with questions, comments, doubts.
And probably I will need to assemble a reading list, and I will do that. Apologies, I didn't think about it.
Okay, thank you so much. Bye-bye. See you.
Thank you.